every previous class, I repeat that same sentence at the beginning of the class. That is, do you find any blank screen shared there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, just a quick recapitulation regarding straight line. Now, for that straight line, which is placed in first quadrant, and this red line parallel to both the planes. Normally, we write it as the name AB. So this is the end A, this is the end B. This is the reference vertical plane VP. This is the reference horizontal plane HP. And AB is parallel to both HP and VP. Now what about the projection? Projections will be, as usual, the plane small a small b, elevation A prime B prime. Okay, remembered? Any trouble there?
No, sir.
Okay, now we do not represent this drawing in this form in 3D manner. This is the formal way according to this subject. So naturally we need to remember this grammar like every new subject. This distance is the height of the line from this HP, and this distance, that is how much it is below the ground line, this is the distance from the vertical plane, this distance. Okay, so as you know, the length of elevation, length of plane, both of them are the real length of the line or the true length of the line, because if the line is parallel to any plane of projection, the projection on that plane will be its true length. Okay. Next, we consider a line perpendicular to vertical plane and parallel to horizontal plane. So when it is parallel to horizontal plane, every point on the line is at the same distance from the horizontal plane. So elevation of every point, including the terminal points A and B, will be at the same height, that is at the same distance measured from the ground line. And it is coming as a point. A prime and B prime, both of them located in its overlapped position. And this is the projection on horizontal plane, that is plan of point A. This is the plan of point B, and connect them. It will be the overall plane of the straight line AB. And as this line is parallel to HP, so projection on HP will be its true length. Okay, and it was the formal presentation in the orthographic projection convention. Okay. Similarly, if the line is perpendicular to vertical plane, perpendicular to horizontal plane and parallel to vertical plane, its plan will be a common point AB. Its elevation will be this line perpendicular to GL, and length of this elevation A dash B dash will be equal to the length of the straight line, the real straight line L. Okay. Next thing, this is the presentation in its orthographic projection, first angle projection system. Okay. Next, the line AB is parallel to the vertical plane, but it is inclined to the horizontal plane at an angle theta. So this is placed in this way in first quadrant. It is making some angle theta with the horizontal plane, but it is inclined, but it is parallel to the vertical plane. So projection on the vertical plane will be its true length, and its projection will show that true angle with the horizontal plane. So angle theta made by the line with the horizontal plane will be available in the elevation when we consider the line is parallel to the vertical plane. Obviously, its projection on the vertical plane will be the real length L, and true angle theta will be available here in the elevation. And what about the length of plane? It will not be the true length because it is inclined to the horizontal plane. So length of plane will be L cos theta. But really we do not calculate L cos theta and draw this line of that length measured in that way. Simply drop two perpendiculars on the horizontal plane, connect these 2 foot of the perpendiculars. And this is the way how we represent that line parallel to vertical plane inclined to the horizontal plane at an angle theta. So this length will be L cos theta. This is true length L. This is true angle theta with the horizontal plane. Okay. Next thing, the line is parallel to HP. Parallel to HP means any point within these terminal locations A and B, every such point will be at same height measured from the horizontal plane. So elevation gives us the height. So in elevation, you will find all the elevation points within that capital A and capital B. The ends of the straight line will be at same height. Ultimately, we get this elevation parallel to the ground line. And definitely, this plan will show you the true length. The plan length is the real length of the line, and plan angle with the GL is the true angle of the line with the vertical plane. So these steps are very important, and you should try to visualize all these things. And next thing, this is the way how we present in the two-dimensional form, that is on a plain drawing sheet or paper like thing. So take a line of that same length, true length of the line at an angle phi with this ground line in plan. In elevation, draw these projectors through A and B. At the given height of this line, this height is specified. You measure that height according to that scale, or scale 1:1, measure the real length, and you locate these 2 points and connect them. It will be a line parallel to the GL. So when one projection is parallel to the GL, so naturally the projection on the other plane will give you the true length and true inclination with this plane. This plane is vertical plane. So this phi is the angle with the vertical plane. Now you must remember these two notations, theta and phi, that these alphabets, these words, the formation rules of sentences, these are rigid like any subject for drawing also. So mostly we will use the symbol phi for angle made by the line with the vertical plane, and angle theta is representing the angle made by the line with the horizontal plane, and it will be available in this form, projection on the vertical plane, when we keep the line parallel to the vertical plane. So these are different orientation of the line, and this is the general form of the line. The line AB of true length L making true angle theta with the horizontal plane and true angle phi with the vertical plane. Now in this case, none of these projections, neither plane nor elevation, will show you the true length. Length of plane will be L cos theta, length of elevation will be L cos phi. And at the same time, these angles made by this plane and elevation measured with respect to GL, this is not equal to phi, and this angle made by the elevation with the GL is not equal to theta. Very important thing. Okay. So length of plane L cos theta, length of elevation L cos phi, relative height between A and B is from this, it is L sin theta, and relative distance between A and B with reference to the vertical plane is this much, it is L sin phi. So these 4 geometrical values must be satisfied. This is the primary clue, but we do not use calculator. We do not measure this length for those calculator values. Simply drawing will give you everything. And for that, what is the starting point? Starting point is draw this ground line, then locate this point A. This should be specified, at least one point should be specified, otherwise everything will be in some floating situation. So identify plane and elevation of the end A. Then at an angle theta with true length L, draw a line. Once this line is drawn, drop a vertical projector. So all these lengths will be L cos theta, etc. Okay. Next thing, draw this line L at an angle phi. At an angle phi, draw a straight line of length L, so that when you draw a line perpendicular to the GL, so naturally this length will be the length of elevation, that is L cos phi. Fine. Next thing what we do, we satisfy the heights or distances measured from the ground line or with reference to the ground line geometrically. What is that? At this terminal point, draw a horizontal line or line parallel to GL, and at this location draw a line parallel to GL. That means this distance is fixed as L sin phi, and this height, relative height between A and B, is fixed as L sin theta. That's all. That is very important step for this. True length L, true angle theta, true length L, true angle phi with HP and VP. A and A dash are identified. So draw horizontal lines through A dash through A. At L theta location, draw a horizontal line. At L phi location, draw a horizontal line or line parallel to GL. It's over. Now, erase this additional information, otherwise it will be clumsy. So next step is, once we have these levels drawn, you project it up to this line, draw a horizontal line at this level, L sin phi level, and draw this circular arc to reach this level and identify this location. It will be point B. Similarly, length of elevation from this location, drop a perpendicular up to this level, then draw this circular arc to its limit. Height is L sin theta, and this point will be the elevation of the end B. And if you draw this thing correctly, naturally B and B prime will be connected by a single line. A single line. Of course, if there is some manual error while using the drawing instrument, the pencil, etc., there might be a little deviation, but theoretically there should be a single line connecting B and B prime perpendicular to the GL. Okay, so these different stages we have learned through our different solution 8A, B, C, D, E, F, etc. Now one part is also there where the line is parallel to the profile plane PP. Sorry. Okay, the horizontal plane, vertical plane, the pictorial plane. Now what we do, we draw perpendiculars from point A and from point B on horizontal plane, on vertical plane, and on the profile plane. Okay, so we get the plan elevation and view from left. What about their names? Small a dash, small a double dash. And for capital B, it is small b dash, small b double dash. So this is the step where we get the plan elevation. Project it on the horizontal plane. This is small a, this is small b. Project it on the vertical plane. This is small a dash, this is small b dash. Okay. Now what about the plan elevation in this situation when the line AB is parallel to the profile plane?
Sir, L cos theta, L sin theta.
वो बेटा मैथमेटिक्स के अलावा तू कुछ नहीं जानता? So first step, this is the ground line. Next step, draw this projector. The location of A and B will be given, or at least A will be given. Then here is the elevation of point, sorry, this is for point B at the lower level. And A will be at some higher level. So elevation A dash, elevation B dash. And so we should write it A, B, because figure is showing very a hazy impression. So this is elevation A dash B dash. This is plan AB. So here is the plan A, the plan B. And now it is our job to draw these straight lines in plan and elevation. This is elevation of the line. This is plan of the line. These two red lines, small ab and small a dash b dash. Do you get my point? And this is a single line perpendicular to क्या? Ground line. Okay, very important information. Now can you tell me what is the true length and true inclination of this line? Naturally, we need to follow the reverse step. What is the reverse step? Reverse step is here. When this line plan and this line elevation is given, the step is reverse, means we need to go back to this location where we have the true length and true inclination with the horizontal plane. So make this plane AB parallel to GL. Simply rotating this length, that is this circular arc, means this length is length of plane L cos theta. And once we have that L cos theta parallel to GL, then what about the corresponding elevation? If it is the new location B1, then it will be elevation of B1, where this plane elevation combination says plane is parallel to GL. So corresponding elevation will be true length and true inclination with the horizontal plane. So this is one step to get the L and theta. Other step is make this elevation parallel to GL. So corresponding plane will be this line showing the true length and true inclination with the vertical plane. Similarly, here also we can do that same thing. Sorry, how does it go? This one. So through A, we draw a horizontal line. Make this elevation parallel to GL. What will be the corresponding plane? Simply drop a perpendicular. So plane B1 is there on this line, and it will be satisfying this relative distance here. So this is the location for B1. Now you join this. So this is the elevation where it is parallel to GL. This is the plane corresponding to that elevation. So naturally, this gives us the true angle with the vertical plane, and this is the true length L. Okay. Similarly, to get the angle theta, we need to make that line parallel to VP. When it is parallel to VP, its plane will be parallel to GL. Its elevation will show you true length and true inclination with the horizontal plane. So what about that? Sorry, there was that ground line also. So here. So make the plane parallel to GL. It means rotate this plane length up to this level. This becomes the new location of point B in plane. What about the corresponding elevation? Draw a projector perpendicular to GL. It will reach up to the level of B. That means it will be elevation of B in its new position. So once we have that thing done, what we have obtained, this is the new plane when it is parallel to GL. Connect A and B in its new elevation location. So naturally, this will be true angle with theta, and this is the true length of the line. This is the formal step according to whatever we have learned earlier. Okay. Now here we will utilize something different, thinking it as a whole, not in this abstract form. Just try to visualize. When any line is parallel to any plane, its projection will show there the true length and true inclination. So when we project this line on this PP, then this is the side view or view from left. Naturally, these letters are not so prominent. I will repeat. This is the capital A, capital B elevation or plane are like this: small a, small b, small a dash, small b dash, and this is side view A double dash, B double dash. Okay. Now, as this line AB parallel to PP, so its projection will show the true length. And one thing, what about these angles? These angles are simply like this angle and this angle, which are theta with the horizontal plane, phi with the vertical plane, and it is here. Okay, so it is very simple to think in that way. Normally it is difficult in the formal way that draw plane elevation. Now in this case, both plane and elevation will be perpendicular to GL. So you can do in that way also. But if you draw the view from left, then it will be in that straightforward manner. Directly draw this side view. You measure the length there, you measure the angles there. It is readily available. Okay. Now, before going to the next part, we'll try to remember for that problem. Sorry, just give me a time. It was in some problem 11 or something like that. Okay. This one. So elevation plan was given. Plan AB. Maybe I need to make it a little more prominent. So this is the elevation for A, this is elevation of B, this is plan of A, this is plan of B. Now draw the side view. So through B, draw a horizontal line to reach up to this 45-degree line, project vertically and move up to the level of B. Similarly for A also, draw this horizontal line, reach to this 45-degree line, draw a vertical projector, then reach up to this height of A, that is elevation A dash. So this A double dash B double dash is the side view. Now once that side view is drawn, A double dash B double dash, naturally you are getting everything from that. This is the true length. This is true angle with the horizontal plane, that is theta. This is true angle with the vertical plane, that is phi. Done. Now some more information is also there, HT, VT, P, Q, P dash, Q dash, but we'll come back. We'll move back to that diagram to visualize it. Okay, so this was that L, theta, phi things available. And one more thing, this thing is as if you have that set square 45 45 or 30 60. क्या रे है आप लोगों के पास सेट स्क्वायर? Am I muted?
Sir, the smaller one present in the geometry
Okay.
boxes.
Now hold it in some vertical position and you bring it to the vertical wall of your room and place it in that orientation, vertical, hold it there and make it perpendicular to this wall also. So it is simultaneously perpendicular to both horizontal plane and the vertical plane. This is that special configuration where the diagonal of the set square is that line AB, which is parallel to the profile plane. Okay, and here we get the true length and true inclination with the horizontal and vertical planes in the form of theta and phi. Now, if we extend this line to meet the horizontal plane, it is the horizontal trace. We extend this line to meet the vertical plane to have that vertical trace. But how to draw this? If we follow that conventional process that we have, this is the ground line, we have the projector perpendicular to that GL. On that projector, we have the elevation and plan. Now, according to that formality, whatever you have learned, that make the line or extend the line to meet the ground line, we extend the elevation to meet the ground line, then find the corresponding plan. Now, according to this location, there may be infinite position on this line which is perpendicular to GL. So it is not easy there. But if you think in some other manner, you see from this side and we consider the line itself projected on the pictorial plane Then extend the side view to meet the ground line. Extend the side view to meet this axis there. What we get then? We get the side view of this HT and VT. Corresponding plan point will be HT corresponding to this, and corresponding to this elevation point will be the VT. And in that formal diagram, that the third part of that problem, here we erase these portions which are not necessary for this discussion to get the HTVT, otherwise it will be clumsy and confusing us. We simply extend the elevation to meet the ground line. Then look at the corresponding plan. We project it on the 45-degree line, bring it back to the plan line. This is the plan point of this location where the line meets the horizontal plane. So this is HT. And similarly, to get the VT, extend this line to meet this end axis. Through this point, find the height. This will be the vertical trace of the line. So as we have seen in that diagram, here. So extend this end view, extend the plan, get the corresponding HT. Now when we extend the line to meet the vertical plane, this is the VT. It is actually extending the side view to meet this end axis, and at that same height, the elevation to be located. So that is the vertical trace. So method is very simple. Just remember, and if you cannot remember it properly, take a set square, hold it in such a position that it is perpendicular to both HP and VP. That is the line which is the diagonal of that set square is parallel to the pictorial plane. And it is that a simple case. Now one thing you can do, just take a screenshot of this page. And this is that special orientation of the line AB parallel to pictorial plane. And from those basic information, you can draw those 3D views, which will give you almost all information about this. Done? Now, if it is understood that is a line AB parallel to the pictorial plane, then draw the plane elevation AB, A dash, B dash, they will be perpendicular to the GL. In pictorial plane, that projection will give you the true length and true inclination with HP and VP, that is theta and phi. HTVT, extend the side view A double dash, B double dash up to the horizontal axis and up to the vertical axis. Corresponding to the horizontal axis position, find the corresponding plane, and for the vertical axis position, find the corresponding elevation. For elevation, you have to maintain the height. For plane, you have to maintain the relative distance from the vertical plane. Okay. Now, next question corresponding to the same problem was that there is, now can anybody read out that remaining part of the problem of 11C? Just go to the problem sheet. First 2 pages of plate number 3, where problem statements are printed.
Find the true length, true inclination with HP and true inclination with VP, horizontal and vertical traces of the lines whose projections are shown in figure problem 11 A, B and C. Also answer the questions in the same figures. P is a point 30 mm from the lower end of the line measured along the line. Find its position in the plan elevation. Refer to figure problem 11A and B. P is a point on the line AB whose position in plan is shown in figure problem 11C. Find its position in elevation. Q is a point on the line AB whose position in elevation is shown in figure problem 11C. Find its position in the plan.
So in this diagram, this P is given. Find out the elevation of P, and in elevation Q is given. Find the position of Q in plane. Okay. Now, would it have been in our previous standard cases that this is the ground line? The elevation planes are like this. This is the elevation, this is the plane. Suppose the names are, now the diagram is very small. Now, can you understand this? Is it visible to your screen clearly?
Yes, sir.
Yes, sir.
Okay. Now, if there is any point P in plane, if it is given, then how to get the P dash, that is the elevation of P? Method is very simple. We project or draw a projector to reach up to this elevation. This will be the elevation of P. Similarly, if a point is there, Q, on elevation, then what about the corresponding plane? Corresponding plane will be on the plane line, obviously, and on this vertical projector. So this will be Q. But when we talk about this, sorry, we need some space. Suppose here. So when we have this ground line, this is the vertical projector, this is the straight line in elevation and in plane. Names are like this: A dash, B dash, and AB. Now, method is what is given, identify that. It is given. Suppose it is Q in elevation. Now, in formal way, draw a projector through that elevation of Q. So how it will look like? It will be simply drawing a line like this and get the intersection with the plane. Now, what is the real intersection of this projector and this plane AB? We do not know. So for this type of problem, when elevation plane both are perpendicular to GL along a straight line, this method will not give you that direct solution. But if you think from the other projector, that is other projection on the pictorial plane projection, there is the side view. P is given. What about its side view? Draw a line through plane, reach up to this 45-degree line, draw a vertical projector, reach up to this level. So definitely it will be side view of point P, P double dash, and its elevation will be that same level and on the elevation line. So draw a horizontal line to reach up to the elevation, and now this is done. So this will be the elevation of P. And similarly, elevation of Q is given. What about the side view of Q? definitely at the same height and on this line. So this is the side view of Q. How to locate it on the plan? Simply trace back by the opposite to that method of getting the side view to reach up to this 45 line, come back along this horizontal line to reach up to the plan line of AB. So now it is done. This is Q. Okay. So please try to understand, try to visualize. Things are very simple, very preliminary. But once you are confused, then it will be really mess for us. So let me clear these. So please go through these problem statements for 11C, that is corresponding to point P and Q, whose one plan is given. Find out the elevation for point P and elevation is given for point Q. Find the corresponding plan. Now regarding other two problems, 11A and 11B, one information is there. What is that? The location of that point P is mentioned. So this is from the bottom of the line at some distance. Okay. So you know the process of how to find the true length and true inclination. So once it is there, go to that true length, measure this length 30 from the bottom and identify this location. This is the location of the point P. And now we come back to its original elevation. So this is the elevation of point P. And rest of the thing is very simple. Plan will be on the projector passing through the elevation of P, and plan will be located definitely on the line, the original plan here. Okay. So find the true length.
So this looks quite dangerous, sir.
Pardon?
So this one looks quite dangerous.
No, not at all. It is very interesting. आप लोग सुडोकू करते हो?
Sir, this is which problem number? Actually, question is not given us, so couldn't relate the solution.
बेटा problem 11A.
Okay, sir. Okay, sir.
अभी तो आपने पढ़ा ना? Along the length of the line from the bottom, measure 30 millimeter. That is a point P. And we need to find out the corresponding elevation and plan of that point P. So first you find the true length. Along the true length from bottom, it is there. But कुछ बोल रहे थे ना dangerous. अब सुडोकू करते हो? क्या नाम सुना आपने सुडोकू का?
Yes, sir.
अच्छा लगता है?
It's difficult to solve, sir.
आपको कौन सा आसान लगता है? कौन सा पजल? क्रॉसवर्ड? न्यूज़पेपर का?
That's easier than Sudoku.
ओके. मुझे सुडोकू अच्छा लगता है, क्रॉसवर्ड अच्छा नहीं लगता. It is something like you go to some hotel and there is a fixed menu card. इडली डोसा भी मिलता है, राजमा चावल भी मिलता है, और मोटा मोटा रोटी जो होता है ना तंदूरी, वो भी मिलता है. ऐसा ऑप्शन भी रहता है, आप कुछ भी खाना खा सकते हो. और कभी कभी ऐसा होता है, देर रात को गए आप होटल में, एंड इफ यू आर नॉर्थ इंडियन, यू आर गेटिंग ओनली इडली सांभर डोसा. वो लोग खाते हैं कैसे? but no option, you have to eat it. So it is something like that. आपको ये समझना ही है, समझाने के लिए मैं हूं ना सर्विस प्रोवाइडर, आप जितने बार सवाल करोगे मैं आंसर दूंगा, बट यू हैव टू मेक इट और यू हैव टू पुट इट एट योर ग्रे मैटर, ठीक है? बट फॉर दैट you take some time, you go through different books, so many solved problems are there, you go to internet, in YouTube there are fantastic video presentations are also there, but you have to give that initial investment. Okay, time दीजिए, ऐसा नहीं है कि अपने आप हो जाएगा, because from the very beginning I am continuously telling you that this is the particular subject which have no root with your school level. ना तो ये algebra है, ना एक कैलकुलस है डिफरेंशियल इंटीग्रल, ना डिफरेंशियल इक्वेशन है, ना फिजिक्स है जनरल फिजिक्स ऑप्टिक्स मैग्नेटिज्म इलेक्ट्रिसिटी, ना केमिस्ट्री है ऑर्गेनिक इनऑर्गेनिक, कुछ भी नहीं है। जो आप इंजीनियरिंग इंस्टीट्यूट में आप एनआईटी में पढ़ रहे हो, मोस्ट ऑफ देम हैव सम एक्सटेंशन, इवन योर स्कूल डेज कंप्यूटर आल्सो, सी सी प्लस प्लस बेसिक एटसेट्रा एटसेट्रा, बट दिस इज द सब्जेक्ट, इट नीड्स ओनली योर एबिलिटी टू विजुअलाइज, दैट्स ऑल। और उसके लिए आप घर में कर सकते हो, एक छोटा सा लकड़ी का लाठी ले लीजिए और इसको घुमा के डिफरेंट पोजीशन में ले जाइए एंड ट्राई टू अंडरस्टैंड व्हाट इज इज प्लान एंड एलिवेशन, दैट्स ऑल। और कुछ नहीं चाहिए बेटा, ना कैलकुलेटर, ना कंप्यूटर, नथिंग। और एक most likely some 1 or 2 classes back somebody was telling me, sir straight line तो simple है। I smiled that day, बेटा गलत कर रहे हो, straight line is the most difficult thing. Okay, but you need to put some time and it will be just नशा लग जाएगा बेटा, आप इससे बाहर नहीं निकल पाओगे। Anyway, ऐसे तो आसानी से नहीं होता है। This is my experience of so many years of being here in this teaching, that I have seen so many first semester people in different batches. Their engineering drawing, their presentation, their understanding so fantastic that even after so many years of experience of teaching this subject, I learned so many things from them and I am proud of those students, really. So beta काबिल बनो and teach your teachers. Okay, that is the challenge you have to accept, and I hope you can do it. And even if you do not do that thing, it will be my failure. Anyway, what is the original diagram? This is the original elevation. Sorry. So this is the original elevation. This is the original plan. Make the plan parallel to GL. Reach up to the level of B. So if it is something like that, A dash B dash, this is AB. You are rotating this line up to this, means you have made this plan parallel to GL. Suppose a new position. What about the corresponding elevation? This is. So think about. So even if you do not able to visualize, just remember this simple tricks. Okay, just mechanically. Plan parallel to GL, elevation will be true length and elevation will be showing you the true angle theta. So if this is the plan, so this will be the elevation. So elevation will be true length and this angle with the GL will be the true inclination theta. That's all. We remember this thing, elevation parallel to GL, plan shows the true length and true inclination with the vertical plane phi. So for problem number 8, different steps are very important. Parallel to both the plane, parallel to HP perpendicular to VP, parallel to VP perpendicular to HP, inclined to HP parallel to VP, inclined to VP parallel to HP, and finally it is inclined to both the planes. And one special situation was there, that is 11C, it is parallel to the profile plane. So next part of what we do, we repeat this process to find out the corresponding plane where the elevation is parallel to GL. So make this plane elevation parallel to GL, that is, this was the original elevation. So make this elevation line parallel to GL, that is by simply rotating along this circular arc. It means that length is maintained. So naturally B will be traveling horizontally. For this location B2 in elevation, plane will be here. Done. So corresponding to this new orientation, this is this combination. So this is true length and this is the angle phi. That's all. So please go through this solved example and repeat it to understand how it is happening. Now once we have these straight lines, a single straight line in its different orientation, now we can think about many number of straight lines forming a polygon. But for polygon, we will not consider those polygons separately for individual lines. We consider that polygon as a whole. Okay. Now suppose you take your class note copybook, okay, and you hold it simply flat on your palm. So what about its shadow on the floor? It will be the exact shape of the rectangle of that copy. What about the elevation? If you bring your eye at that level of that copy, it will be a simple straight line projected on the vertical plane. So you have to think it as a whole. And suppose we have some solution. Let me check. Here, problem C, suppose 7. This is the smallest shape of a polygon. Only 3 sides. Angular lamina ABC has the corner capital A on HP and 25 mm in front of VP. The plane of AB is at 45° to ground line. B is 50 mm above HP and 50 mm in front of VP, while C is 10 mm above HP. The plane ABC of the lamina is an equilateral triangle of the 3 points. Capital C is the nearest to VP. Draw plan and elevation of the lamina and also view from left. So many informations are there, but we need to start from the simplest thing. What is that simplest thing? That is, the plane ABC is an equilateral triangle. So highlight that. The plane ABC of the lamina is an equilateral triangle of the 3 points. So this is the thing, ABC. Okay. But what about the clue? Clue is C is nearest to the VP. What is the distance that we do not know directly? What about the other information? Other information, a triangular lamina ABC. Now can you rather read this thing properly? Is it big enough to read on the screen? Problem statement: a triangular lamina capital ABC has the coordinate capital A on
Yes,
HP.
sir.
Okay.
Yes.
Now concentrate on the first clue. Corner A is on HP. Any point on HP, what about its elevation? On the ground line. So this is the point. What about the corresponding plane? A on HP and 25 millimeter in front of VP. So measure this distance 25 and identify the plane small a. That part is over. Now from A, we have to proceed either towards B or towards C. The plane of AB is at 45 degree to ground line. Now plane of AB, that is small a small b, it will be definitely available in plane. A is already known. So from that A, draw a line at an angle 45 degree. So draw this line at an angle 45 degree. As it is mentioned here, that plane, sorry, just a minute. Oh. The plane of AB is at 45 degree ground line and B is 50 millimeter above HP. So along this line 45 degree, B will be placed. And what about the elevation of the point B? Elevation of the point B is definitely connecting this plane and elevation by a single projector, and at this height. What about this height? Elevation of B?
Sir, 50 millimeter.
50 millimeter. But directly you cannot locate this elevation point because plane point is not identified. Only thing, it is located on that 45 degree line. That's all. A is fixed. Then what about the other clue? While C is 10 millimeter above HP, so C is 10 millimeter above HP, and this is for A. For B, the plane AB is 45 to the ground line, B is 50 millimeter above HP and 50 millimeter in front of VP. Oh, for B, that 50 millimeter above HP and 50 millimeter in front of VP, that is given, that complete information. Suppose we have a ground line, we have this projector, and this is informed that a point B is 50 millimeter above HP, 50 millimeter in front of VP. So this is plane and elevation. But in this case, it is not known. So you cannot locate this also. That means the position of this projector is not known. Only thing, level of elevation and distance of plane, it is given. But we are not sure about the exact position of the projector. But it is given there. How? It is given in this form. If you go through the statement carefully, that you will find that this 45 degree line is corresponding to the plane AB. And what about the distance of B from the ground line in plane? That is distance of point B from the vertical plane. What about the distance of B from the vertical plane? It is 50 millimeter. So at a distance 50 millimeter, we draw a horizontal line and get the point of intersection with this 45-degree line. So this point of intersection will show you the location of the plane B. Done? Now through this point B, draw a vertical projector and meet this level 50 millimeter to get elevation of B. Okay? Then what about C? ABC is an equilateral triangle. So once AB is determined.
One doubt, sir. Sir, but the position of B is exactly.
Ek minute better. Once
Okay.
AB is determined, then how to get the point C? Because it is that clue. ABC is one equilateral triangle. So AB is known. Draw a 60-degree line here, draw 160-degree line, or simply making this distance as radius AB and draw two circular arcs, get the point of intersection, it will be C. It could be on this side also, but it is not, because C is the nearest to the ground line. It is nearest to the vertical plane. Okay, so it will not be on this side. So once C is known, we know the level of C in height. So draw this projector, meet this level, that is elevation C. Now you just tell me what is your problem. Let me erase this clumsy information bunches.
Yes, sir. Sir, the position of B is known. It is 50 millimeter above HP and 50 millimeter in front of VP. And we have found out the position of B dash. So can't we simply draw the vertical line to find the uh, position of B? Because it is 50-50 only.
Okay, ground line is known. This is at 50 millimeter. This is also at 50 millimeter. But at what location? Is it here? Is it here? Or it is here? Along this 45-degree line? You need to pinpoint this location B. B should be on plane line AB, which is at 45-degree line. And it will be at this 50 millimeter distance. Then only you can satisfy both this clue and find out this. Then only we draw a line through this plane point perpendicular to the GL and meet this level. Then only. So first thing, a triangular lamina ABC has the corner A on HP. And 25 millimeter in front of VP. So on HP and 25 millimeter, this is step 1. What about step 2? The plane of AB is at 45-degree to ground line. So this is step 2. Okay. Then what about step 3? B is 50 millimeter above HP and 50 millimeter in front of VP. That is step 3. We know only this horizontal line, only this horizontal line. Okay. Then get this level intersected on this 45-degree line. Then naturally this will be the location B, because this is the plane AB line. This is the level of, or the distance of plane B from the ground line, that is at 50. Once it is determined, then we come here. So it is level 50 millimeter. Then this location This is the determination of point B. Then this is the fifth step. Okay. Next step is C is 10 millimeter above HP. So draw a line 10 millimeter. This is step 6. We do not know the exact location of C in plan or in elevation. But one thing we know that ABC will be one equilateral triangle. Taking this length AB as the radius, draw two circular arcs. So this will be step 7. And now you come to this. This will be step 8. What about the side view or looking from left? At this level, at this distance A, for B at this location projected here up to this level of B double dash. Automatically C is also up to 45-degree line, a vertical projector up to this height of C dash. This is C double dash.
Sir, in case I'm not able to visualize the side view, I can do it simply with the help of that 45-degree line.
Of course, in all cases, visual ability might not be available with anybody. But at least we must understand the thing, at least mechanically, that this is the process. Anything in side view will give us this primary logic of construction. That is for any point in plan elevation, if it is given, suppose B, plan of B, that is small b, and elevation of B, that is small b dash, it is given, then first step of getting the side view is from B, draw a line parallel to the ground line. This is the first step. Of course, before that first step, this should be the original first step, that is 45-degree line. So we start from this point in plan, we reach it here, then draw this vertical projector to reach up to this level, and initially it will be extended little bit. Then step 3, through the elevation of B, draw a horizontal line. So this intersection is the step 4, that is B double dash. Now do you understand?
Yes, sir.
Okay. So similarly other things also. This is the special location A, which is on HP. So naturally there is no height. Anything on HP means it is on the ground line itself. So this is the location. But the distance from the vertical plane will be like this. This much distance to be maintained perpendicular to this profile axis. Okay. Now regarding other, I think problem 5 was discussed. It was discussed in detail. Other problem 2 was also discussed, 3 was also discussed. No, this is problem 3 actually. I have written 2A, it should be 3A. 3 parts are there, 3A, 3B and 3C. Now this 3C part, here you will find it is parallel to the profile plane. Okay. This 3B, it is another special configuration. Draw elevation, plan and view from right of the line CD, where C is on HP and 30 millimeter in front of VP, while D is 35 millimeter above HP and on VP. The distance between the projectors of C and D being 40 millimeter. Okay, so that 40 millimeter to be satisfied. Point C on HP means elevation on ground line. Point C 30 millimeter in front of VP. So this is 30 millimeter. This is plan C. At 40 millimeter distance, draw this vertical projector. D will be here as it is on the HP. It is on VP. So elevation will be on the ground line. On VP, sorry, from distance from VP is in plan, so distance is 0. So plan is at 0 distance from the GL, and the height of that point D, it is 35 millimeter above HP. So this is the 35 millimeter. So identify this also. Now join these 2 points C dash D dash, that is the elevation. Join these 2 points CD, that is the plan. Now with reference to this problem, if we draw one thing, anyway, we should take help from some this one maybe. Now, can you try to visualize this thing?
Cone.
It is one half cone. Maybe 50% of that half cone is below the horizontal plane. Okay. Then what about the surface? The surface is formed by infinite position of the generator. This is one position of the generator. This is another position of the generator. This is another position of the generator. Here also, in this way, we form that half cone surface. This is the center line. Okay. So if this is end A, and these are different position of B on the base circle, B1, B2, B3, B4, etc. Then can you think about any special information in this problem? Now, if instead of that, if we consider one cone standing vertically, so this conical surface is formed by infinite position of this generator. Am I clear? Now, what about the angle made by this generator with the horizontal plane?
Sir, constant.
It is constant at an angle theta. Similarly, here also, we are simply considering the other way, that is, it is as if it is not possible to stand on the vertical plane, but geometrically it is equivalent to this, that this axis is perpendicular to the vertical plane, and we are considering half of the cone, as if 50% is below HP, 50% above HP. Then the length of the generator is same, and the angle made by the generator with the vertical plane, that is also same. That is angle phi. And one end is fixed, the apex of the cone. Other end of the variable position straight line, AB, 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 etc. It is taking different position B1, B2, B3, B4, B5, B6, etc. But wherever you go, length of the line is fixed. Angle made by the line with the vertical plane, that is also fixed. And special clue is that the other end is located on the vertical plane. So whatever may be the position of B, it is definitely on the vertical plane, and its plane will be on the ground line itself. So that thing is considered for that second problem. This one. C is located on the horizontal plane. So its elevation on the ground line, and D is located on the vertical plane. Its plane is on the ground line. So simply, even if you cannot visualize, you are not able to do that, but at least mechanically you try to understand that a point on HP means there is no height of the point. Height is available in elevation. So elevation distance will be 0 from the GL. So C dash is on the HP, on the ground line. And similarly, D is on the vertical plane. So its plane is on the ground line. That's all. So projectors through C dash, projector through D will be like that. Distances are given 30 millimeter, 35 millimeter. That's all. The distance between the projectors is 40 millimeter. So I hope there is no problem to think in that way also. But visualization is that special ability which clears almost everything regarding the problem of the straight line. Now, when you solve a problem of 2D coordinate geometry, y is equal to ms plus c. Okay. So y is equal to m1x plus c1 and y is equal to m2x plus c2. What about the point of intersection? We have two lines. This red line having y-axis positive intercept C1. The angle with the x-axis is θ1, tan θ1 is equal to m1, and we write it in this form, y is equal to m1x plus c1. And the green line is corresponding to, in similar way, m2x plus c2. Now, what about the point of intersection? On the graph paper itself, at a distance c1 and c2, we identify these two y-axis intercept. We measure the angles θ1 and θ2 and draw two lines passing through this intercept location C1 and C2. And physically, we can find out the location of this point of intersection and find the coordinate of this point, x value, y value. But if that graphical visualization ability is not there, mathematically, how do we do that thing? We write these two equations. You replace y in terms of x in the other equation. So get the value of y from this equation 1 and put it in the other equation 2. So you will get the relation between x, m1, m2 and c1, c2. That's all. So similar kind of thing we are working here also. So at least if we do not have that ability of visualization, this geometrical logic we must understand that C is on HP. So elevation C dash will be on the ground line, and 30 millimeter in front of VP means the plane will be on the projector at a distance 30 millimeter because plane distance is available. Plane distance gives us the distance from the vertical plane, and elevation distance gives us the height from the horizontal plane or distance from the horizontal plane. That's simply like that. Okay, and the same problem we can use for determination of the true length and true inclination. It is something like this problem. If you try to visualize so B is on HP means the point capital B itself is the plane of B. A is on VP means the point A itself the elevation A dash. And next part is very simple. You join elevation points A and B and plane points AB to get the elevation and plane. This is elevation and this is plane. And this red line connecting capital A and capital B, this is the real line whose one end is on VP, other end is on HP. And these are the individual projected lines perpendicular to GL, perpendicular to GL. That's all. क्या है ठीक है थोड़ा टाइम दे बेटा So you purchase any book on engineering drawing, it may be, as I mentioned, it may be ND Bhatt or K. Venugopal, but that is not my rigid choice. You have your own preference, whatever you get. Even from the internet also, you can find so many free materials that also you can download and please go through, okay, and solve different kinds of problems. Okay, now after this straight line, we are talking about different polygons, pentagon, hexagon, etc. And there was one curved boundary problem here. We have discussed it in your previous class. These informations you have to understand as a whole, that draw planar elevation of circular lamina of diameter 50 millimeter when it is inclined to H by 30 degree and perpendicular to VP. So we start from this horizontal position of the circular plate. Then it is a straight line when it is parallel to HP. And in plan it will be a complete circle. But this curved line is a continuous curved line, there is no straight part. So we assume it to be combination of 12 very small straight lengths when we subdivide it uniformly at an angle 30 degree and give the point names. And finally you will get that almost that ellipse when we consider these 12 points. Otherwise, would it have been 24 points? It would be more accurate, but we don't have that much of time in examination hall to just take so many number of points to get one almost accurate shape of that projected boundary. It's not necessarily we have to compromise with the accuracy and the time, but this thing is good. 12 subdivision. Okay. Now this is making 30 degree with the horizontal. This is the stage. Rotate it. Correspondingly, all these points will get shifted here. But what about the plan? Simply it will squeeze. You can try with make a circular plate, and initially you start with the horizontal position, then gradually you tilt it with the horizontal plane. You go on making some angle. Elevation will be that same length, that is the length of the diameter. But plan, that shadow will be smaller and squeezed and squeezed. Finally, it is going to be ellipse in that way. Diameter is the major axis, minor axis reduces. And when you take this circular plate perpendicular to the horizontal plane, that shadow will be a straight line. So when theta is 90 degree, it will be a straight line here. But that is the special configuration for this perpendicular to GL plane elevation combination. It is that circular plate is parallel to the profile plane. So in side view, you will get that true circle, exact circle you will get. The next part, draw planar elevation of the same lamina when it is inclined to HP at 30 degree and one of its diameters is parallel to both HP and VP. Now we can remember that configuration of the straight line when it is parallel to both HP and VP. So this is the ground line. If these are the projectors, then plan and elevation will be parallel to GL. Now here, if we consider these names of these definite locations along the boundary, then 17 is one diameter. Correspondingly, 280 is another diameter. 410 is also one diameter. So this diameter 410 is perpendicular to GL, and it is a single point here overlapping with the elevation of C, the center. Now from this configuration of a line perpendicular to VP parallel to HP, how we can make it parallel to both the plane? Simply rotate it through an angle 90 degree. Now it becomes the new position, and now it becomes the new position of that same diameter 410. Okay, so earlier it was 4, it was 10, and this point was 410. Now the 10 is shifted here, and correspondingly 10 is shifted here. So this is the diameter 410, this is the diameter 410 in planar elevation, both parallel to GL. So line itself is parallel to both the planes. That's why we rotate it through 90 degree, so that this line 410 is parallel to GL, and automatically this point will be giving us corresponding diameter 410 parallel to both the planes. So only thing, once you determine this ellipse, this is the initial configuration. From that you rotate it through 30 degree, get this one, get the corresponding plane, just satisfying all these distances same. Next, this 90 degree rotation of this whole figure, there you need to do very carefully. The distances have to be satisfied. So first thing, we draw these reference center lines, measure these distances. So draw this line 410, draw this line 17 with these distances plotted there. Next thing what we do, from this line 410 travel perpendicular to this distance, perpendicular to that by this much distance, and from this reference line move perpendicular to this line by this much distance, and in that way we can get the location 5. Similarly for 6, this perpendicular, we get location 6. Okay, so this is the lengthy process of copying all these 12 points, but it will not be the copying of 12 points, because once we can identify the point 2 and 3, the mirror image location will give you 5 and 6. On this side 11 and 12, and either 5 6 mirror or 11 12 mirror will give you 0.89. That's all. Okay, so this is not very difficult to understand. Only thing, process will take some time. You do not consider it in the form of combination or composition of 12 small lines, and don't think in that way of drawing plan elevation of line 1 2, plan elevation of line 2 3, plan elevation of line 3 4, etc. It is simple that boundary locations 1 2 3 4 up to 12, and think the circular plate as a whole. And to think that circular plate as a whole, this is the primary configuration where we get the full circle in the form of a line. Here also it is inclined to HP but perpendicular to VP. We get in this full straight line form. So full information. So any point located on this circular plate, it is on this line. So when you think about, or when you take up the problems of plates or lamina or some polygon, you think it as a whole, and starting configuration should be either it is parallel to HP perpendicular to VP, or it is parallel to VP perpendicular to HP, so that you can get this type of combination, that one view is in the form of a straight line here, other view is the true shape. So this is the starting configuration. So that you need to understand what should be the starting configuration, so that very easily with a single step you can reach to the final stage of drawing what is mentioned or you have been asked for. But for that, that ability to work with these instruments, the pencil, eraser, without making the drawing sheet clumsy or dirty with so many pencil dust, etc., and repeatedly erasing all these things, nahi chalega. You have to be very careful about all these things. Okay, bolo.
Yes, sir. Sir, after drawing the first figure, and then we'll draw the horizontal lines, and then we'll for the figure 18A, we'll draw the in the vertical plane, we'll draw the inclined line. So, sir, how do we get the points exactly like 2 and 3? Because if we draw horizontal line from that inclined line, that is in figure 18A. So, sir, that exact location of 2 and 3, how is it happening?
So first stage of drawing is draw a horizontal line of length at the diameter of the circle. What is the diameter? 50 millimeter. What about the position? 40 millimeter. That is the first step. You know point 1 and point 7 now. But even you do not think about the point 1 and 7. Just draw a horizontal line which gives you the diameter. Okay? Then you draw the complete circle in plan. What is that? Center should be at a distance of 35 millimeter. So at 35 millimeter, you locate this center C, taking radius 25 millimeter, draw this circle, then subdivide at an interval of 30 degree from this horizontal line, clockwise 30, 60, 90, 120, 150, and then 180. Okay, and go on marking these points: point 2, point 3, point 4, 5, 6, 7. Sorry, 7 is the extreme boundary, rather the diameter end. Then 8, 30, 9 at 60, 10 at 90, 11 at 120, 12 at 150, 1 again, come back at 180. Now, once we have these 12 points in plan, what about the corresponding elevation of these points 1, 2, 3, 4, 5, 6, etc. up to 12? The full plate is represented in elevation by this single line. So any point, so all these infinite number of points on this circular plate will be located on this single line only. If we consider any point here on the plate, suppose point P, its elevation will be, primary logic is, plane elevation will be connected by a single projector line, and elevation will be located on this whole elevation of that circular plate. So similarly, for 1 and point 7, these are the extremities. Okay, and for other points, for point 2, 2 dash will be along this vertical projector, and elevation is located on this horizontal line. So this will be for 2 in elevation. Similarly, for 3, project it. This is 3. For 4, on this projector, this is 4 on this elevation line. Similarly, for 5, on this projector, on this elevation line, for 0.6 on the vertical projector and at this level of elevation, and 7 is here. And once these are determined due to mirror image positions, 8 and 6 will be coming at the same location. 9 and 5 will come at the same location. 4 and 10 at same location. 3 and 11 at same location. So give the corresponding names, 2 and 12 here. So it is not mandatory to give the names 1, 2, 3, 4 up to 12. But for first semester people, it is necessary to give the names. Otherwise, after 1 or 2 steps, we will be in a mess. We cannot connect the real position of the previous figure and the new figure for new orientation. So it is useful to mention all these names 1 to 12 in plan and 1 to 12 in elevation. Done. Then when you consider the second stage, that is the circular plate is inclined to horizontal plane at an angle 30 degree, then make this line rotated about this point and shift by angle 30 degree. And once it is that, the distance between 1 and 2, distance between 2 and 3, distance between 3 and 4, everything is satisfied here. Distance between 1 and 2, distance between 2 and 3, distance between 3 and 4, identically these things are there. This one is here. This distance is between 2 and 3. This distance is between 3 and 4, etc. So simply use your divider compass and go on cutting these lengths. You mark it here and cut it along this 30-degree line and give their names. And once you rotate this figure in this way, we do not make any change for the distances measured from the vertical plane. So distance of 1, distance of 2, distance of 3, distance of 4, everything will be maintained in its new orientation also. We do not calculate, we do not measure it from the scale. What we do? From 1, draw a horizontal line, and from the new position 1, draw a vertical projector, get the point of intersection. This is the plan of A, plan of 1, because new plan distance and the old plan distance, same distance. For point 2, this is the old plan distance, and when you draw a line parallel to GL, so corresponding to 2 on the same vertical projector, point 2 will be there, that same distance for point 2 in previous plan and in new plan. Okay. And you know, for the third stage.
Yes, sir, I got it.
Okay. So for everybody, I should give this suggestion that whenever you are not having any question, at least listen to the other people's question, whatever it may be. So the discussion about that question may help other people also. So please concentrate on other people's question. So that is for the curved boundary. And let me see if any other curved boundary or straight boundary problem we have done or not. This is the pentagonal boundary. That is for the straight line 11. It is for the straight line 10 to find HTVT, etc. All these are very simple. For visualization, you can make yourself this type of diagram. And this is the compact diagram that you should understand, and this is the final diagram. If the problem is reverse, that is plan and elevation are given, find the true length and true inclination with horizontal and vertical planes theta and phi. We should trace back this thing, make elevation AB parallel to GL, get the corresponding plan. This new plan will give you the L and phi. Similarly, make the plan parallel to GL, get the corresponding elevation. The new elevation will give you the true length and true inclination theta with the HP. And another configuration, it is not there, but that is the line parallel to the profile plane. Here, for that minimum cell structure, that is the triangle. Okay. So for a polygon with minimum number of sides, here from this description we need to understand everything stepwise and stage wise. That's all. So if graphically you do this thing, C1 and C2 intercept on y-axis, slope theta 1 and theta 2 you measure and draw these lines red and this green, and this is visible. This is graphically you can determine this location. Of course, pure mathematical calculation in your calculator will give you the most uh, correct value, but graphically if you do that, some error will be there, measuring the distance, measuring the angle, etc., etc. But these things are very helpful. At least visually you can have some idea the range of x and y for this. So x cannot be more than this, with of course acceptable or admissible 5-10% error. Y cannot be more than that for that point of intersection. So it is something like that. Otherwise, it is pure mathematical solution. We don't need to draw these things. Simply put this y value m1x plus c1 in the first equation, in the second equation. That is m1x plus c1 is equal to m2x plus c2. So c2 minus c1 is equal to m1 minus m2 multiplied by x. So x is c2 minus c1 divided by m1 minus m2. And that kind of simple relation. But it will be helpful for 2D cases. But for 3D cases, this pure mathematical or vector solution is the only way to do that thing, because for most of the 3D cases, it is not possible for us to draw those diagrams. Particularly once you are drawing that 2D presentation, it is very confusing. Now, have you heard about the skew lines?
Yes, sir.
What is
Yes.
that?
Yes, sir.
What is that? बताओ क्या है skew line?
Two line in different planes.
Non-parallel,
The
non-intersecting
lines
lines.
don't intersect
Sir,
each other.
same line of
Non-parallel, non-intersecting lines.
Exactly.
Yes, sir.
Now, can you find the distance between the minimum distance between these two lines? Skew lines, mathematically?
Yes sir.
कैसे?
वेक्टर 3D में सर डॉट प्रोडक्ट करके नॉर्मल के अकॉर्डिंग करते हैं.
इसका very simple solution है drawing में. बाद में सीखेंगे. But anyway, if you have some interest, you can go through any drawing book and try to find out that interesting thing there. Now, corresponding to this plate, hopefully we are now confident about all such situations. These are some special configuration. One point is on VP, other point is on HP. But truly speaking, length of plane, length of elevation will be L cos theta and L cos phi. Relative height will be L sin theta. Relative distance between A and B measured from the vertical plane is L sin phi. So all this mathematical information are automatically satisfied from these drawing procedures. This is the real line capital A, capital B projected on the horizontal vertical planes to get the plan elevation. This is the plan elevation presentation, is the formal way for this subject. Then we extend the line to meet the horizontal plane, that is called the HT. So automatically its elevation will extend up to the ground line, its plan will extend up to this HT. And this is the way how we get this thing formally for its orthographic projection. Extend the plan to meet the ground line, get the extend the elevation, get the corresponding plan. It means through this elevation draw a vertical projector. You extend the plan backward other towards B, get the point of intersection, it will be HT. Of course, HT and plan of HT, they are at same location because the point itself is on the horizontal plane. Similarly, for this also extend in vertical in inclined upward direction to meet the vertical plane. This is the vertical trace of the line. Necessarily elevation will be extended, plan is also extended, but this point is on vertical plane, so its plan will be on the ground line. So this is the way. Extend it up to the ground line, get the corresponding elevation that is on the vertical projector and on this elevation extended. That's all. Extend the plan up to the ground line, this vertical projector, and this is the elevation extended. Okay, this is some special situation. This is another special situation where HT and VT both above the GL. That is one thing is in second quadrant. This is another special orientation, line parallel to profile plane. So this location of point P and Q in plan and elevation are given. Find the corresponding elevation and plan. And this location of P, P dash, or P or Q for here, you need to determine the true length, and along the true length we measure the true distance. Then we need to come back to this original thing. So this is the true length. Locate it here, find the corresponding elevation and find the corresponding plan. That's all. This is just elaborated, enlarged view. This is the second part 11B, that 11C, parallel to the profile plane. The pentagonal lamina. Here we need 12 points to give along the boundary and draw individual plan elevation of these 12 points and think the circular plate as a whole, not distinct 12 points, because these are connected by this logic also. The continuous connection of these points in sequence, it will give us a closed boundary, a circle. Its shadow, when it is you make it inclined to the HP on the other plane, it will be that ellipse. And for helping regarding visualization, the line AB parallel to HP and VP, elevation plan both parallel to HP and VP, line perpendicular to VP parallel to HP. So elevation a single point, plan perpendicular to GL with true length, parallel to VP, perpendicular to HP, elevation true length, plan overlapped. This one parallel to VP, inclined to HP at an angle theta. This is the corresponding plan elevation. Here inclined to VP only, but parallel to HP. So plan is inclined at the true angle phi, what the line is making with the horizontal plane, that is the vertical plane. Here it is the general configuration. Line of length L making true angle with HP theta, true angle with VP, that is phi, and this is that. This is the special configuration for line parallel to the profile plane. This elevation plan both perpendicular to GL. So in formal way you cannot find the HT and VT. So you need to come back from the, or you can do it, but some clumsy process you have to make, but this is very distinct and straightforward. So extend this side view to meet this profile axis, extend this side view to meet this horizontal axis, and that's all. So extend the line itself to get the VT and HT. The same thing we get it from here, and find the corresponding elevation and plane. As if this is the set square of 60/30. Anyway, let us close the discussion on straight line today. In the meantime, before our next class, you do one thing, please go through the chapter projection of simple solids from any book, from any source or any resource. Okay. And in that case, you don't think that any solid is combination of infinite number of points. It has got specific boundary and objects are very simple. It is simple solid. Now, how we can form a pyramid? How we can form a pyramid? Just tell me. बेटा इतना सोचने का क्या है? This is not examination. कुछ गलत आंसर भी दे चलेगा.
So three triangles means three triangular planes if we attach.
Not three, four.
Oh yes.
Base is square and three triangle, four triangle are around.
So there should be one base. Okay. Now base may be a triangle. The triangle may be equilateral, may or may not. Base may be a rectangle or a square. Base may be a pentagon, regular or irregular. Next step is the geometrical center of the base. Somewhere here, somewhere here, somewhere here, somewhere here. Next, directly above this base center, we identify one location okay. Then from that location, we draw several lines connecting the base corners. So basically, we have the base polygon, either this irregular triangle, this regular triangle, or this rectangle, or this regular or irregular pentagon. This is the base polygon. And how many more faces are there? And what about their shapes? All other faces will be in the shape of triangle. And how we form those triangles? By simply connecting this vertex of the object or apex O with the base corners. And these are the triangles OAB, OBC, OCA, OAB, OBC, OCA. Then for this one, OAB, OBC, OCD and ODA. And here OAB, OBC, OCD, ODE and OEA. So ultimately, whatever may be the way we make this solid, this axis is perpendicular to the base, the geometrical axis. So this point O is directly above this base center. And from this word right angle, we name these objects as right object. This is a pyramid, a right pyramid of base triangle. This is a right pyramid with base triangle. Here it is right pyramid with base as rectangle. Here it is the right pyramid with base pentagon. Clear? So the base, either it is regular or irregular, and the axis, whether it is perpendicular to the base or not. So in that case, either it will be the right object or it will be oblique object. How it is oblique object? Suppose this is the base. The axis of the object is the line connecting the C and O but this is not perpendicular to the base. It is then simply formed by connecting this location O to the base corners. Sorry, this repetition is there for the central location C. This is the base center. Forget about the name. So for this object, this line connecting the base center and this vertex of the object, it is not a line perpendicular to this base. Okay, so this is oblique. Okay. Next thing, regarding boundary of this object, how many points are there? What
4 points, sir.
A, B, C, and O. How many lines are there? A, B,
6.
C, A, OA, OB, OC. How many areas are there? One triangle ABC, other triangles OAB, OBC, OCA. So if we draw the plan elevation side view of this simple object, we have to locate 4 points, capital A, capital B, capital C, capital O, that is A dash, B dash, C dash, O dash. How many lines we have? 6 lines. So AB, A dash, B dash, BC, B dash, C dash, CA, C dash, A dash. And OA, O dash, A dash, OB, O dash, B dash, OC, O dash, C dash. And 4 triangles. But truly speaking, if we follow the primary idea of projection of points, projection of straight lines, and projection of lamina, it will be really confusing for us to satisfy the geometrical relation between different locations, different straight lines, their angles, their true lengths, etc. We need to think the object as a whole, and that is the beauty lying there regarding this projection of simple solids, which is truly speaking very easy compared to the projection of straight lines and projection of surfaces. Straight line is the most difficult thing. Of course, it is a single line connecting two terminal points A and B. It sounds very simple, but difficulty level is quite high. Then the surfaces, base surface ABC and 3 triangular surfaces, side surfaces OAB, OBC, OCA. We don't think in that segregated manner of projection of 4 triangles. We think about the whole object. Okay. Now let us find one more blank page there. And normally things are like this. This is the vertical plane. This is the horizontal plane. Suppose this is the object Now you just tell me, one triangular base pyramid is resting on horizontal plane with one of its base edge perpendicular to the ground line. This one. this is the height of the pyramid. So when we project it in on vertical plane and on horizontal plane, the base itself is coming in this form. The base of the object and base of the plane, those are same overlap thing because it is resting on the horizontal plane. If it is O, these locations are A, B and C. Now AB is perpendicular to VP. So plane AB is perpendicular to GL. Project it here. This will be elevation AB. And project the point on the ground line. C is on HP. So this will be elevation C. Now height of the topmost point O, that height H is there. Find the geometrical center of the base by simply drawing two medians, get the point of intersection. Project it on the ground line. Project it vertically. Measure the height. This will be elevation O dash. Next you join O dash with A dash, with B dash, with C dash. And in plan, we identify the location O in plan, connect it with A, connect it with B, connect it with C in plan. That will be the plan of OA, plan of OB, plan of OC. Now, as you know, 6 lines are there, AB, BC, CA, the base triangle lines, and OA, OB, OC, those side connecting lines. So naturally 6 lines you will get in plan and elevation. So in plan, this is AB, this is BC, this is CA. For OA, OB, OC, this is OA, this is OB, this is OC. And in elevation, this is the plan of O, naturally corresponding elevation of O will be here. So this line is OA, this same line is OB, this line is OC, and here on the base we have AB, BC, CA. From A to B, this line is overlapped as a single point, B to C and C to A. So finally, when we work on this formal 2D presentation of this projection of simple solid, we will draw this ground line, then draw the base figure, that is of the triangle of given side. Find its geometrical center by simply connecting or drawing these medians. This is the geometrical center. It will be the plane of that apex. The vertically above this, you project it, there will be the elevation of this topmost point. Okay. Next thing, for plane of A and B, it is here. For plane of C, it is here, that is on the ground line because the object is resting on the horizontal plane, that is the floor. Next, draw these 6 lines. AB is the single point represented line. BC is this line. And CA is that same horizontal line on the GL. Then elevation of OA is this line, O dash A dash. Elevation of OB is also this line, O dash B dash. And this is elevation of OC, that is O dash C dash. In plan, this is the plan of O. So what about plan of OA? This line connecting plan of O and plan of A. Connect the plan of O and plan of B. This is plan of OB, and connect plan of O and plan of C. This is plan of OC. So we think the object as a whole. This is resting on the HP. One of its sides, that is capital A, capital B, is perpendicular to GL. In plan also, plan small a, small b will be perpendicular to GL. And this is the whole thing. 6 lines, AB, BC and CA. Then OA, OB, OC in plan. 6 lines in elevation, AB, BC, CA. Other OA, OB and OC. Confirm? But we never consider in some segregated or separate manner that 4 individual points O and ABC we need to locate. 6 different lines we need to consider, AB, BC, CA and OA, OB, OC. 4 different triangular plates to be considered, ABC, OAB, OBC and OCA. Not in that way. In overall view, the object is placed on the base on the horizontal floor. So its base will be coming in the form of a straight line placed on the GL. What is the starting orientation? One is AB is perpendicular to GL. That's all. So start from this, draw a line perpendicular to GL, identify location A and location B. From the given logic of the base triangle, whether it is isosceles or equilateral or any arbitrary shape, find out the location of C. That's all. Height of the object is given. So find the base center, draw any two medians, get the point of intersection. From that point, draw a vertical projector and measure the height h along that projector and locate this elevation of the point O. That's all. Then simply connect the elevation points OA, OB, OC, AB, BC, CA, and the plan points AB, BC, CA and OA, OB, OC. That's all. Similarly, if we think about one cylinder, this is the top surface, this is the bottom surface, this is the solid boundary like thing. In plan, this is the plan itself when it is resting on the HP. In elevation, it will be rectangle. Width is the diameter of the cylinder. Height is the height of the cylinder. So on the formal presentation, how we do it? This is the base of the cylinder. This is the horizontal extremity of the cylinder. That is the diameter. And this is the shadow form on the vertical plane. Simply height of the cylinder and the diameter. That's all. It could be, instead of pyramid, it could be a prism also. A triangular base prism, a square base prism, rectangular base prism, pentagon base prism. But we need to think as a whole about the solid. So please go through some material on this projection of simple solid. In the meantime, I will give you the mail regarding that problem sheet on projection of simple solids. Some problems are discussed there, some problem statements are there. So have some preliminary idea. Okay. Now before we discuss about any other confusion or any of your question, I need to take your attendance. Already I am late. And it is only 90 people showing there, 91 including me. So people, those who are not right now here in the class, those will be recorded as absent. Okay. So from your side, do you have any question on the point line surface or this discussion about the solid what we made right now?
The last class you told about taking some tests. So is the date already given?
On this drawing?
Yes, sir.
No, it is not given. It will be sent to everybody, that information, because if by any chance you are missing any class and that announcement is there, okay, test will be tomorrow, and you do not know and miss the test, it will not happen in that way. From my side, it will be my responsibility to inform everybody that this test will be on that day, this will be the portion to be considered, this is the way how do you make the solution, this is the way how you submit the answer, etc. Everything in detail. And by this time, definitely you know the date of examination of your mechanics, that is 22nd of March.
Yes, sir.
Okay, and that is there in the most likely in the website or from Dean's communication, you know it, and that will be for 2 hours and 60 marks and full syllabus. Whatever you discuss till the last day of the semester, it will be there. Okay then, so please permit me to close the session.
Thank you, sir.
Okay.
Thank you, sir.